Now let us look at the next problem. Two statements are given, and based on what you read in the statement 1 and statement 2, then you have to choose the correct option. Whether statement 1 is correct, statement 2 is correct, and if statement 2 is the correct explanation of statement 1 or not. Okay, now let us look at the first statement. Two particles moving in the same direction do not lose all their energy in a completely inelastic collision. Second, principle of conservation of momentum holds true for all kinds of collision. Now we know that this statement is correct, and let us look at the first statement. Try to do some mathematical calculations on this. Okay, let us say you have two particles having mass m1 moving with v1 and mass m2 moving with v2. After the collision, which is inelastic, they move together jointly with the uniform speed v. So principle of conservation of linear momentum would apply. m1 plus m2 into v, that is final momentum, will be equal to initial momentum m1 v1 plus m2 v2. So v is equal to m1 v1 plus m2 v2 divided by m1 plus m2. And we know that the kinetic energy is given by half mv square, which is equal to half m1 m2 into v squared. Okay, which can be further written into as half p square by m1 plus m2. Okay, so this is the expression. Now what is this p? P is the final momentum. Here you can see this momentum p, final momentum p, cannot be 0 because p1 plus p2, if the addition of both p1 and p2 is 0, that means if simultaneously the momentum of both the particles is 0, then only you will get kinetic energy equal to 0. Okay, there is one more possibility that you have same momentum p1 and p2, okay, but the particles are moving in opposite direction. Okay, and if this in magnitude is equal, p1 is equal to p2, in that case the two bodies will come into rest. But in the question, in the statement 1, it is given that they are moving in the same direction, so that possibility is also ruled out. So p1 and p2, the addition of both cannot be 0, and both of them cannot be 0. p1 also cannot be 0 and p2 also cannot be 0 simultaneously, because if this is the case, that means initially the bodies were not moving at all, and if they were not moving, then there is no question of elastic or inelastic collision. Okay, so based on the discussion and slight mathematical portion that we did on statement 2, we can say that statement 1 is correct. We cannot lose the entire energy in completely inelastic collision. Okay, so statement 1 is true, statement 2 is true, statement 2 is the correct explanation of statement 1. Now let us look at the next problem. Again, similar type of problem. Statement 1 and statement 2 are given to us. We'll read both of them and then we'll find out whether the statement 2 is the correct explanation of statement 1 or not. When ultraviolet light is incident on a photocell, its stopping potential is V0 and maximum kinetic energy of the photoelectrons is Kmax. When the ultraviolet light is replaced by X-rays, both V0 and Kmax increase. Okay, now we know that, let us say this is a photocell surface, okay, and it has got a phi as its work function, and if the incident radiation having frequency nu is incident on it, and if nu is more than nu naught, that is threshold frequency, then electrons are ejected out of it, that is photoelectric effect. Now this electron has some velocity v or kinetic energy k. Now the maximum kinetic energy that this electron can have, the ejected electron can have, is equal to the difference in h nu minus h nu naught or h nu minus work function phi. Now we are writing the maximum kinetic energy because there is a possibility that electrons may be ejected from the inner surface, and before they get finally released from the surface, they may undergo further collision. So they may reduce a portion of their kinetic energy during the collision. So the maximum energy is the one in which the photoelectron is ejected right from the surface, and it does not collide with any other metal atom or any other electron. Only in that case those electrons will have maximum kinetic energy. And to stop those highly energetic electrons, you need a stopping potential V0, which is given by K max divided by E, or H nu by E minus phi by E. Okay, so now we know that K max will be this kind of function, that is K versus nu. If you plot, if the frequency of the incident photon is more than threshold frequency, then it increases linearly. Okay, now in case of UV and in case of X-ray, we know that X-rays are more energetic, or the frequency of X-rays is more than that of the frequency of UV. Okay, so if frequency is more, then K max is also more. Okay, in the same way, stopping potential V0 or Vs is also this kind of function. If frequency is more, you will have more stopping potential. So the statement 1 is correct. Now let us look at the second statement. Photoelectrons are emitted with speeds ranging from 0 to a maximum value because of the range of frequencies present in the incident light. Now there is no range of frequency in the incident light. It is a monochromatic light, and photoelectrons get ejected with variable energy because they collide intermittently with other electrons or metal atoms before they finally eject out of the surface. So that is why they have a range of kinetic energy. Okay, so statement 1 is correct, but statement 2 is not correct. Therefore option D is right. Okay.